Data, data, data. What do you do with so much data? How do we collect data? Well, one way to do that is through a tally and frequency table. We use these tables to help basically count what is going on with our surveys and our responses. In a tally and frequency table, we have a few different columns. We have 3 different columns. We can have our category here, and then for this example, we're saying what type of pet do you have? So do you have a dog, a cat, a goldfish, a budgie, a hamster, a lizard, and so on. And then we also have our tally down here as well, where we can also just quickly put a slash for every person that answers that. And then at the end, we can actually count the frequency. Notice tally and frequency tables both have them, where if you just say a frequency table, typically you don't always need to show this tally. This is for categorical type of data. You can also use these frequency and tally tables for numerical data, where you'll have your class intervals or your sizes, which say with numbers. So this is, for example, a class's results from a test and what score they got and how many people got those scores. Obviously, in total, which we should always have at the bottom of the frequency table, has a total of 40, so it should always add up. We'll look at this one again later, why it's quite, well, not quite right. So in this example, again, this is also used for numerical data. We look at what the class interval is, what their score is. So students who basically got between 0 and 39, there's only one student there. Students who got between 40 or from 40, including 79 as well, got 5. Students who got from 80, including 80 up to 119, we can see that we counted 12 here. Students that got from 120 to 159, we've done a tally here, we've got 8 here. So keep on going on with the tally. We do this just as a recording. Normally we'll have the raw data and we just put them down in here just so we can count how many are in that set. We should always have a total, or not some, I'll probably write total down here, and then that would add up to 31 for this scenario here. One thing I do want to talk about, especially with numerical data, when we're doing class intervals, let's just have a quick look at this one, is you should always have the class intervals as an even size. As we can see here, there's actually 40 numbers in here, 0 being actually a number. So like 0 is really 1, then 2, then 1, then 2, then 3, then 4, then 5, and so on, 6, 7, 8, 9, 10, all the way up to 39. There's 40 in there. There's also 40 in here. What's really good is that we should always start the class interval at a nice whole number, not be starting on an odd number. Why we do this is because when we construct a histogram from this will help us construct a histogram, we actually show this interval starting at 0. This one will start at 40, this one will start at 80. I'll prepare one and show you what I mean. So this histogram is made from this frequency table. As you can see, we have the frequency or the count along the side here. Down the bottom, we have the class interval sizes. Note that I've only done 0, 40, 80, 120, 160, 200, and 240, with both these numbers written under every single tick. What this indicates is this actually indicates where this column actually starts. So let's look at the very first one and work through this. This very first one actually starts at 0, and we can see there's about 1 in there, and it's 0 up to 40, but not including 40, which matches up with our class interval from 0 to 39. We've only got one person there. Then we have 5 people with scores between 40 up to 80, but not including 80, but it includes 40. And that's why we actually start off the class intervals with these nice numbers. Don't be a fool and do it the other way. And I'll show you some examples of that soon. So again, moving to the third column, which is our highest. So if asked what's the highest, we can display this. This is how they match up. We have 12. We've got 12 people in this column. And we also note that this starts from 80. So these people include scores from 80 up until 120, but not including 120. Hopefully this makes a bit of sense and you can see each of these intervals and how they work. Again, what we want to always make sure we have is we have between 4 to 14 of class intervals. We don't want to make it too compressed when we do this drawing, and also we don't want to stretch it out too far either. We want to make it pleasing to the eye to see because again, data is just about displaying it and we can interpret because a picture is worth 1,000 words. So our class intervals should always have the same break in them when we're dealing with numerical data. And in this case, they always have 40 in every single one. So they're quite easy to use. Just make sure you've got a good class interval. And again, we want between 4 to 14. We don't want any shorter than 4 groups in here. And we don't want any more than 14 groups in here. So this has 1, 2, 3, 4, 5, 6 groups. That's a pretty good number there. Anywhere about 8 to 6 is really good. The one criticism I do have is that jumping by sizes of 40 probably isn't the most conventional. If we jump by groups of 25, for example, we could have gone up to 250, and that would be 10 class intervals. So we could have gone 0 to 24, 25 to 49, 50 to 74, and so on. Let's look at some losers. There are some really interesting ones here. Notice this starts at 21 to 30, 31 to 40, 41 to 50, 51 to 60. That is just not really good maths. Whoever made this, I do not know why they're doing it. This group should really be going from 20 to 29, 30 to 39, 40 to 49. Because if you did a histogram of this one, it would look really silly. Here's a little sketch that I did, just showing what the histogram and how it would be silly. Obviously down the bottom, starting at 21, 31, 41, 51, doesn't really look too good. So that's why I wouldn't do that. Here's another great interesting one. Remember we did this one at the start of the lesson. Let's just make that a bit bigger. If you look at this, this goes from 20 to 30. This one goes from 30 to 40. This one goes from 40 to 50. This is a super common mistake I see a lot of students doing. Let me just ask you this. If someone got a class result of 30, where would you put the tally mark? I mean, I would have to put it here, or would I put it in both? Because both of these include 30 and it's not very clear to me whereabouts I put 30. Now you're only going to record the 30 once because it's one person's score. You can't record it twice because then it just stuffs up all the data. So this should really be from 20 to less than 30. Or we can say from 20 to 29 if it was rounded. We'll look at how we can actually do these less thans a bit later on. Hopefully you can see what's wrong with this one as well. Again, we can see it goes from 210 to 230, 230 to 250. These have class intervals of 20 between them all, which is fine. But I mean, if I got 230, where do I put it? If I got 250, where do I put it? Again, it's jumping up by quite an odd number. I don't really like that. Why wouldn't you just go with 25s or 50s? You know, start at 200, go to 224, go from 225 to 249. This is just not appropriate. I can't find actually how many mistakes. I can find a heap of mistakes on the internet. I can't believe how many there are. People just don't understand actually how to display data correctly. So here we go, we've got something with less than. So this is saying, hey, it's greater than 0, but this group will also include 20. Well, that doesn't make sense because you want to actually not include 20. So this is not right. This should be, so this is so badly done in so many places in the world. I had to actually create one myself. So let's look at this, what's happening with the height. So people in this category would be, well, 0 height, which is near impossible, but we're going to include it anyway, up to not including 20, which makes sense if we actually then needed to transfer this category, or these class intervals, I should say, into a histogram. This one here is saying that these people include someone who's 20 centimeters tall up to 40. This category here, this class interval, I should say, not category, this class interval would be people who are 40 centimeters, including up to 60, but not including 60. So it could be like 59.99999 centimeters. Okay, that's someone who would be in there. But as soon as they hit that 60 centimeter exactly mark, they're going to fall into this category. Clearly now this gives me a clear distinction, unlike the other ones. If I have someone, for example, who is 40 centimeters long, they're not going to put them in this group because that's less than 40 centimeters. They're going to be in here, which makes sense with our histogram. So this is what the frequency table would look like as a histogram. Obviously, starting including 0 up until 20 would be in here. We actually can see there that we have 4 people. And so on, we can count all these. So we have 13 people between, or not between, including 20 centimeters up and 2, but not including 40 centimeters. Then we also have 19 people, including 40 centimeters up until 60 centimeters. And here we've got 2 people who are measuring between, well, not between, from 60 centimeters, but up until 80 centimeters, but not including it. Hence, doing these actual class interval sizes is really important to make sure you get those correct. Again, we always want to include the first number, what it is, and we want to end on a number of just less than that we're going to start with. And you want to choose nice interval sizes. What's the problem with this, you may say? Well, I can pick a few problems. I mean, we've only got 4 class intervals here. Personally, I could have actually gone with 10 centimeters, which would have given me 8. And it'll give me a better display of the data, because obviously it could be a bit cramped up here. I really want to know that. Now you might be asking yourself, hey, I've never met anyone who is like 0 to 20 centimeters or 60 to 80 centimeters, 40 to 60. There's a lot of them. Well, if you maybe thought about it, this is actually the birth, the measuring of a birth, children at birth. And normally they're between 40 to 60 centimeters is the most common. We can clearly see that there's a few kids who are between 0 and 20 centimeters, and wow, some monster babies between 60 and 80 centimeters. No, we're just going to call this a frequency table. We should also have a total in here and add this up, like so, which makes it a lot better now. So from here, we can read anything. We can say what's the most common, or what's the most common height of a child born. Well, I can say it's anywhere from, it includes 40 centimeters up until 60 centimeters. How many people were in the survey? Well, there was 31 children in this survey that we count. So this is for numerical data. One thing I do want to know is that we've actually lost a lot of the raw data. We don't actually know what specific height these kids were. I mean, we could have had 4 kids who were 19.7 centimeters, or we could have had, one kid who's just like 10 centimeters. We could have had another who's 19.2, 19.8, 19.7. We don't actually know that. So with continuous data, we typically group these into class intervals, and we also do it when we have a wide range. Sometimes though, we can actually keep the raw data with histograms. Note that these ticks on the side of each of these boxes indicating what this box starts with and includes on the left up until that number, but doesn't include that number. So if I had someone who measured 40 centimeters, they would be put into this one, not the one on the left. So for discrete numerical data, we can have frequency tables like this. These actually we can see the raw data in here. So if I ask how many siblings you have, we can see in this survey 57 people have no siblings. We have 29 people who just have one brother or sister. We've got 31 people who have 2 brothers, like maybe a brother or sister, or 2 brothers or 2 sisters. We don't know. We can see we've got 3, if you've got 3 siblings, 61 people, 4 siblings, 26. Clearly we had no one more than that there. Now we can actually display this as a histogram. This histogram, we can actually keep the raw data. Note here, the number is actually directly under this histogram of the bar of this histogram. Now we do call it, I'm going to call it a bar. It's not a bar chart, it is a histogram. Let's just call it a column either if you want to call it that. But note that actually then indicates that this actual value of this whole graph is 0. Everything in here is 1. Everything in here is 2. Everything in here is 3. Everything in here is 4. So if I just have this graph by itself, I can still actually pull out the raw data, because I can see that we've got about 57 people, if it was labeled better on this axis, who have no siblings. We also have 29 people who have 1, and we have, and so on, 31 who have 2. Now note, if it had a scaling like this, where it was 0 to 1, this would then represent, this includes numbers from 0 up into 1, but not including it. I mean, obviously, if you're talking about siblings here, we can assume it's 0, so you wouldn't actually do that anyway. But if it was a different scenario, you've actually lost your raw data, because I don't know if numbers in here are like 0.1, 0.2, 0.3, or whatever. I don't know the raw data. But from here, I can see that the numbers that fall in here are between 1, including 1, up to 2, but not including it. So that's the difference between where we actually put these in. So when you actually have a whole number, and here I don't need to don't need to put them together, because we've got 1, 2, 3, 4, 5 class intervals. Whereas if this went from, like, number of siblings went from 0 to, like, say, 30, I would actually have to then split that into groups of 5, which would then give me 7 class intervals. And again, then that would be 0, 5 would be here, would have then 10 on this one, and so on, and we'd have to actually tally and join them all together. But anyway, we've gone a bit far in depth there, but that's okay. Let's leave it there. Best of luck with it. So you can read anything from a frequency table. You can just pull these out. You can look at those. You can look at what the most frequent number is. So if I say, hey, what's the most frequent number of siblings someone has, we can see that it's 3. However, you've got to look at the frequency table. It's a bit awkward to look at, which is why we display it. Again, a picture is worth 1,000 words, and all we're doing there is just trying to make it pretty simple for people to read it. If I say, hey, what's the most common group, I can just see that this one's the highest. And hey, that is a lot easier to see that it is 3. For categorical data, what you can do is we can still use the tally frequency table, and here you'll see which cars may be drying. We can do a tally here, put the total. And if it is categorical data, how we display that is as a column graph. So notice you'll have the color underneath of the car and the frequency obviously along the side. The difference here is we actually have gaps between them. That's what we do always for categorical data. So you can also have a key with the side if you want, with showing what color represents each of these categories, or alternatively you can just label them underneath. Don't forget you also need to label your axes, color of graph, and also the frequency along the side here. Like this one here, you've got color of cars, we have a key, and we can also see number of cars sold along the side here. I can have a quick look at this one, see what color the cars are. Obviously it corresponds, but I can also look here, blue, got 4 there, sold 5 whites. I've sold 15 reds, and I've sold how many greens? If we look across, we can see 6 and 5. So obviously the most common color here is red. Maybe it's a Ferrari garage, because I'd only want a red Ferrari. But I'll tell you what, they're selling a lot of Ferraris if this is done in a week. So hopefully you know now the connection between frequency table and why we make frequency tables, because really it helps us either design a histogram if it's numerical data, or it helps us design a bar graph or a column graph if it's categorical data. Again, please make sure you're doing the right one. You've got a bar graph for categorical data, or you have a histogram for numerical data. Good luck. I'll see you guys soon. Over and out.